Hi everyone. Can everybody hear me? Okay, thank you. We'll just wait for like another 5 minutes and we'll start. Okay, so I think everybody's inside. So today is the first practice session that TAs will handle. And before we start the practice session, I just want to remind you that around 40 students still haven't completed their surveys. So please make sure to get it done by this Sunday. Also, I noticed that some students who did submit their surveys might have entered their student IDs incorrectly. So, but don't worry, I'll send out a reminder email today to those who either haven't participated yet or made a mistake with their student ID. So no need to concern about it. All right, so let's get started with today's lecture. By the way, if you have any questions, feel free to ask anytime through Zoom. Yep. So today we're going to cover plotting with Matplotlib library and dive into some basic machine learning techniques like linear regression, logistic regression, support vector machines, and more using scikit-learn. So everybody downloaded this file, right? So let's start. So we first import some necessary libraries like NumPy, Matplotlib library, and scikit-learn. We run it. And first of all, we'll see the examples of how to plot in Python. So we use Matplotlib library, and for basic, there are two things. So there's plot and there's scatter. So for plot and scatter, we input the listings of x coordinates and listing of y coordinates. So for this is like you can think of it as 1, 1, 3, 2, 2, and 3, 1. And plot is for making continuous line, and scatter is just plotting the points, the data points. So let's run the second one. If you run it, so it's plot. So it shows the line from 1, 3 to 3, 1. And for scatter, it's just the data points. So yes, you can see there are 3 points, and we can also plot them together. So you can be seen like this. And so this is really basic one. So let's start drawing a real function. So let's say we're drawing this function, and first of all, we define a function. Oh, for those of you who doesn't know what the lambda is in Python, you can just use it like this. Oh, sorry. Like define foo access input and return this one. Okay. So yeah. So we first define a foo function. This is this one, what we want to draw. And let's say we want to, so we define the x, and first of all we use line space, line space, yeah, line space. So this one's actually what this one is doing is it creates 100 data points from 0 to 10. So as you can see, there is 0 and from 0.1, 0.2 to 10. So there are total 100 data points. And so we make y data points. So we input x line into foo function, and this will be the same as the shape will be the same as x. You can see here. And let's redraw this function. So plot, as I said earlier, the plot takes x listing of x's and listing of y. So we put inside x line and y line and redraw it. So this is how it looks like. So this line looks smooth because we draw 100 data points, but let's say we're just like drawing 5 points, and it'll be look like something like discrete. Yeah, so you see the difference? So as you make more data points, the line becomes more smoother. Yeah. So this time we will do with 100 data points. Okay. So on top of this function, we'll make 10 data points with noise on the foo function. So what it does is like we first define how many samples, samples we want to make, and we make x data points on same one from 0 to 10, 0 to 10, but with 10 sample sizes. And for the y-axis, we add the noise with normal distribution with mean 0 and the variance 0.1. And so there is x sample and y sample. And if you scatter them, so scatter was like just putting the data points. So if we scatter them, the point looks like this. So we take the x from this function. I mean x from just 0 to 10, and we sample the y function with some noise. And if we put them together with like the original x line was like original this function. So if we put them together, it looks like this. So oh, I'm sorry. I don't see this file in KLMS. There is in the KLMS. You can find it. There is the name of it is like this one. Yeah. Okay. So as you can see, it's not on top of the function because it's the noise added to each data points. So something is below or something is above. And you can like change the color. Like color is like, well, how do I call it? Orange. Yeah, you can see the differences like this. Yeah. So this is really basic methods to draw a function in Python. So any question for this now? Okay. So um So why are we making this noise function? So in here, we define the target function foo and added Gaussian noise to sample data points like here. But in real world, the order is different. So using these data points, we have to we have to know what the original function looks like. And for new data points, like for example, like here, we have to predict the y value. So this time we will using these orange data points, we will uh, do the linear regression. And where was it? So these are the orange data points, y x sample and y sample. So let's see how it looks like. So yeah, it's just one dimensional array with 10 data points. And for linear regression, there we use scikit-learn linear model. We use linear regression from this module. And it's really simple to do this. So we just define linear regression and just this magic word fit. So this does all the stuff by themselves. So let's do it. So yeah, if we run this code, there's an error. So like, but why do you think there is an error? Um, this is because like the fit function, there is a predefined shape of fit function. So let me show you how to use this in using this our chatbot. Where is it? Okay, so like there is an error. Load. Yeah. To run this. Okay, so the example has to be 2D array, so it has to be reshaped. So let's do this one then. So we reshape it. Yeah, so this works now. So the original data shape was just one dimensional array, but if you reshape it, like as example reshape -1, 1, then shape. So it's two-dimensional array, but with same data points, but just the dimension becomes different. So this is the way to input the X in linear regression fit. And yeah, so there's the answer. And so after you can think of it as just training. So after we fit, we can predict a new data point. So for example, let's just input example again. And if you run this, this time we use predict. And if you run this, there's also an error because predict the shape of X in predict should also be same as fitting. So it should also be reshaped to two-dimensional array. So if you run this code, yeah, so it runs. So the Y hat now has one-dimensional array with 10 data points, and this is predicted one, and the original is Y sample. Was it Y sample? Yeah, it's Y sample. Yeah. So this is the original one, and this is the predicted one. Yeah. Oh, there is one. Okay, so this is X, this is the original Y, and this is the predicted Y. And we can measure mean square error. So with Y and Y hat. So we first subtract them and square them and mean it. So when we do this, the mean square error, you can get it. And we can plot them how it looks like. So I'll show you. So if we first plot them, no, it's not plot. Example, let's do this one. Yeah, it's right. So if we plot them. So this is the predicted linear regression line and the original data points, including the original data points. Yeah, so this was the original data points, and let's also do this one. So PLT plot X, what was it? X line, Y line, X line, Y line. Why X must be two-dimension? Okay, so the reason is that so this is really basic sample, so we are just doing with one-dimensional X, we're predicting Y. But let's say, for example, like there's X-axis, Y-axis, and you want to predict Z-axis, and there are two-dimensional in input. So like for more, I'll just show you the implicit example, like how does it look like? Um, oh, we can tell this one right here. Y is Y, X, just be two-dimensional. Yeah. So if X were allowed to be just one-dimensional, it would imply that there is only one sample, I mean, one features. So this would make it ambiguous for a model to understand how to interpret the data. So like if the the features are three-dimensional, you have to like there are three features and you have to use it in linear regression or whatever. The x-axis has also have to include these features. So that's why the x the they're enforcing 2D structure in X. Yeah. Where were we? Yeah. So let's draw the original line. Color. Let's separate it. Oh. Yeah. So this was the original function that we have to predict. And these orange lines were the sample data with noise. And this blue line is what we predicted using linear regression. So you can see the differences. And well, this is really like don't know how to discern. So let's add the legend. You can also use the legend like this. So I mean, like I'll show you how to use this one. So from below code, around below code. Let's see. I want to add that legend for plotting X line, Y line is original function for plotting X sample and Y hat. It is sampled data points with noise. And for no, it's this one. And for scattering, scatter. For plot X sample Y hat, it is what was it? Scatter plot. It's predicted line. Yeah. Predicted line using linear regression. Yeah, so okay, if you run this code, yeah, so it shows the code. Let's just use it instead of it. Yeah, so this one shows that the red line is the original function. These are the sample data points with noise and predict the line with using a linear regression. So this way you can use like this chat function to add some details. So yeah. Any questions for now? Okay, let's move on. So for now, this was like really basic one. So we knew how to draw function and data points, really basic plotting. And we also plotted some like this high dimensional function. And we made some noise and also use them to predict new lines like this. And now we'll do the actual data. We'll use the actual data, which is iris dataset. So iris dataset is like classification dataset with widely used in machine learning. So it contains 150 samples from like iris flowers. I don't know what it is, but and the task is to classify whether this is like Setosa versicolor virginica. So there are three labels we have to classify, and there are four features like sepal length, sepal width, petal length, petal width. So these are the x's, x, and this three are the y that we have to predict. And for the question that as one student asked why x must be two-dimensional, so this is why. So there are four features that we have to use in our x. So like in here, where was it? So yeah, so for this x sample, it looked like just one array, but for let's say for this iris data set, there are like there are sepal length, sepal width, petal length, and petal width. So this this is for one data, and there are like so for one and two second data, third data, fourth data. So these are the axes that we have to use. So that's why this linear regression fit takes the two-dimensional input. Yeah. Okay, so we can load this iris data using scikit-learn datasets. So yeah. Oh, so what is the return x and y? You turn this off. I don't. You turned it off. Oh, there is an error. Yeah. If you want to know what this thing this thing do, you can just ask this one. So what is turn x y? Okay, so if this is true, it returns x and y. If it's false, returns bunch object dictionary like objects. Oh, so okay. Sorry. What if I set it to false? Yeah. So if I set it to false, I have to use it like dictionary. So I have to put some keys inside this function. So yeah, you can use whatever you want, but this time we'll just turn it on, return. So how does the x and y looks like? Yeah, so x is two-dimensional array. So 150 is data points. So it's data number of the data, total data, and y is the number of features. And this y is the classified value of these three, Setosa, this one. So let's actually see how the data looks like and why. So it's 0, 1, and 2. I don't know what 0 maps to either one of these three, but yeah, this is what the Y looks like. And let's use them to train classifiers. So from scikit-learn, they provide splitting the data set into training set and test set. So we use this train test split function. So what train test split takes is the x, y, and how much you want to do, how much data, how much test size you want to make for this. So it's 20% and the random state. So if you run this, so test size was 0.2. So 150 times 0.2 is how much is it? 30. So we can see that y test is the size of it is 30. And yeah, it's 30. So we got x train, x test, y train, and y test. So let's print it off. And x train. Oh, this is all the things by themselves. Okay, yeah. So x train is two-dimensional array 120, 4. X test is 30, 4. Y train 120 and y test 30. Yeah. So using this data, we will train logistic regression, support vector machine, and decision tree. And as we the where was it? As we did here on top, it's just the same. You just use this fit function. So and inputting two-dimensional array in axis. Yeah. So the X train and Y train X train is already two-dimensional, so you don't need to reshape it. So what this is doing. So why are we just inputting two dimensions? So what's this one doing? Yeah. So there are 120 data points and 4 features, but as you know, 4 features are difficult to plot it. So this is why we are just using 2 features, maybe just sepal length and sepal width, and we are not using this just for plotting because we are going to plot these below. But if you want to use it, if you want to like fully train, you want to make a best model using this iris dataset, you can just ignore this. But this time we will plot this, so we'll just use two features. So yeah, let's run this. Oh, what are these things doing? So what's C, what's kernel, what's degree, what's max depth? To be honest, I don't know. So like there are so many features, so many like hyperparameters for each module, so you can just do whatever you want with the training dataset and just pick what's the best for the training dataset. Well, sometimes there's also like validation dataset. So you train with train dataset and test it on valid, and you set up your hyperparameter and finally test it on test dataset. But this time we'll not do those things, but you can just change whatever you want. You can actually ask here from below what are the other options hyper parameter for each classifier. Let's run this. Yeah, so for logistic regression, they have C, penalty, solver, max iterator plus tolerance. So there's also C. Yeah, this one and kernel, there are linear, poly, RBF, sigmoid, pre-commuted, degree, gamma, coefficient 0, and for decision tree classifier, there are criterion, max step. There are a lot of things, so you can just do whatever you want to fix this. There are no like golden answers, so yeah. Let's run this just over to simple way and predicting it. So first, we used here also predict, right? Where was it? Same as using linear regression. Yeah, we also use predict. So we predict you for this support vector machine. Let's predict and run this. And so this is the predicted Y label, and this Y test was the original target. So we check how much this machine has corrected. So 73% were correct. So let's change this. So let's change this kernel. Let's change this to kernel to like linear. And if we run this code again and predict it and this, oh, it's the same. Why is it the same? I don't know why it's the same. I think the dimension is too low to like classify that there are only two dimensions, so like it's too low to like compart. Yeah, so but if you change this X train and do it, the score will be different. So yeah, we can also check like, oh, so by the way, so we predicted the Y target and we compared it with your target Y test, but the simple way is just like using this. So you use SVC, the score, and you give X dataset, you put here, and the target variable here. So this automatically predict and compare with the target dataset. So if you run this, it's the same. And you can also, we also trained decision tree and logistic regression, so you can run it. And so support vector machine was 73% were correct. And for decision tree, 56% were correct. And for logistic regression, 73% were correct. Yeah. Actually, let's like use the full one. So let's not use just two features. Let's run all. Oh, I don't know what it means, but yeah. So and let's run this again. This time this has to be different. Oh, let's compare using 4. So yeah, as you can see, when we use only two features, 70% was right. But when we use like full feature, they're correct, like 100% correct. And for decision tree, I think one or two datasets were wrong. So these are the difference. Oh yeah, I have to run it again because I have to plot it. Sorry. Yeah, back again. And let's plot it. So this y logistic is predicted value using logistic regression, and this one is predicted value using support vector machine, and this one is using decision tree. So what this function is doing is like first, the subplot means like for So I'll just run it first and tell you guys. Yeah. So first of all, we'll define the figure size here. And what this subplot means is that for 1,4 coordinates, so it's 1,4 coordinates, you plot this one into the first one. So it's 1,4 and you do it in the first, you do it in the second, you do it in the third here, and you do it in the fourth. This is how we use the subplot. And we define a title. So for logistic regression, SVM, decision tree, ground truth. And we scatter. So it's data points. So we put X test and X. What's the skill? What's this one? X. Ah, yeah. So as I told you earlier, we are just using two features. For example, we are just using sepal length and sepal width, not using petal length and petal width. So in x-axis, we are just using the first feature, and for y-axis, we are using the second feature and not using the third and fourth feature. And so these are the x. So this time the y is not the target. So the color is actually the target. So for color, we input these y logistics. So what it's predicted. So let's see the ground truth first. So for ground truth, so these are like the ground truth that we have to classify. And comparing these two, you can see that for here, these are different. So this is what we have to predict, but these are the predicted value for logistic regression, support vector machine, and decision tree. So I think, yeah, so for support vector machine and logistic regression, their accuracy were same. As you can see here, the classification looks exactly the same, but for decision tree, some of here are different using this, and this is why the accuracy differs. So yeah, you can plot in this way and adding boundaries. So for in this figure, you can also add some boundaries, like how there should be a boundary inside. So let's also use this one using this string. From below code, I want to add decision boundary to each. Let's run this. Oh, this shows a lot of code. Let's just use this and run it. I hope this works. Oh, that's good. So logistic regression, they make a line like this. And support vector machine is a little bit different. The actual classification is same, but the decision boundaries are different. And for decision tree, they make like this. The decision boundary looks like this. So yeah, these are today. These are uh, how you can add decision boundaries. Like I wanna explain you like details of how this function looks like, but it's like too specific details. So if you want to like do it on your own, you can use this our TA AITA for more detail. But I think the paradigm has changed in coding. So like 4 years ago, like 3, 4 years ago, like when you have to code, you had to understand all the details of like what this function does, what does this variable means. But I think these days, the key is how effective you can use GPT in your coding. So I think you don't need to understand all of the details. You just have to know how to use it. So I want to like, for example, I want to make decision boundary here. That's it. If you like, I want this I want decision boundary, you can use GPT. to make it. And this even applies to our project. So like because we are not abstaining you from using the AI in project. This is because it has changed, so you don't have to memorize all to do the code. Okay, so this is it for today. So I think it ended really earlier. So you, so yeah, this is to end of today, and I'll last for like 5 minutes. So if there is any question, I'll just get more questions. Yeah, you can leave the class if you're done today. Thank you, everyone. When will the project guidelines be released? So the project was like, oh, when was it? Wait a minute. I think the guidelines will be released like after Korean Thanksgiving. Yeah, but you don't have to worry about the project. It's really easy. Any more questions? I'll stand here until 5 minutes, so you can ask whatever you want. You can also use mic. You can unmute it and just ask me. Next Thursday's class will be proceed. So yeah. So I think next Tuesday is Chuseok, right? So next Tuesday there will be just like recorded online lecture. So there is no like real-time class, but in Thursday there will be real-time class. Yeah. Can you show me again the prompt that you used for final code? Okay. Yeah. So like I just copy and pasted the old code and like just edit from below code. I want to add decision boundary to each. Okay. Yeah. You can use this chatbot in your like learning PyTorch because it's really helpful to use this and it'll help you a lot in your coding experience. And for those of you who didn't still completed your surveys, please make it done by this Sunday. And I will today send you emails for those who did their surveys, but their student IDs are wrong. So yeah, but you haven't done it yet. Please do it. Okay, so I think everybody just yeah, there are no questions anymore. Okay, so I will end the class today and see you. Well, today's my last session, but yeah, see you next time. Sorry, but I finished the survey yesterday, but I'd like to check whether my survey was good or not. Um, you mean like your students' IDs were right or not? Yeah, thank you guys. Um, 성, may I enter the link again? Yeah, you can do it if you want to. I'll just use the last one. But don't worry, if you didn't enter your student ID correctly, I will just email today for those who didn't, they're not in our database, so you don't have to worry about it. But if you're worried, you can do it again for now, yeah. Okay, guys, I will end the lecture today. Hope you guys have good day today. Yeah. Bye bye.